Bcrypt is a key derivation function for passwords designed by Niels Provos and David Mazières, based on the Blowfish cipher, and presented at USENIX in 1999. Besides incorporating a salt to protect against rainbow table attacks, Bcrypt is an adaptive function. Over time, the iteration count can be increased to make it slower, so it remains resistant to brute force search attacks even with increasing computation power. The Bcrypt function is the default password hash algorithm for BSD and many other systems. The prefix $2 or 2y in a hash string in a shadow password file indicates that hash string is a Bcrypt hash in modular crypt format. The rest of the hash string includes the cost parameter, a 128-bit salt, and the 192-bit hash value. Blowfish is notable among block ciphers for its expensive key setup phase. It starts off with suitcase in a standard state, then uses this state to perform a block encryption using part of the key, and uses the result of that encryption to replace some of the suitcase. Then it uses this modified state to encrypt another part of the key, and uses the result to replace more of the suitcase. It proceeds in this fashion, using a progressively modified state to hash the key and replace bits of state, until all suitcase have been set. Provos and Mazières took advantage of this, and took it further. They developed a new key setup algorithm for Blowfish, dubbing the resulting cipher X Blowfish. The key setup begins with a modified form of the standard Blowfish key setup, in which both the salt and password are used to set all suitcase. There are then a number of rounds in which the standard Blowfish keying algorithm is applied, using alternately the salt and the password as the key, each round starting with the subkey state from the previous round. Crypto-theoretically, this is no stronger than the standard Blowfish key schedule, but the number of rekeying rounds is configurable. This process can therefore be made arbitrarily slow, which helps deter brute force attacks upon the hash or salt. The iteration count is a power of 2, which is an input to the algorithm. The number is encoded in the textual result. There are implementations of Bcrypt for Ruby, Python, C, Perl, PHP, Java and other languages. Algorithm: the Bcrypt algorithm depends heavily on its X-Blowfish key setup algorithm, which runs as follows. X-Blowfish setup, cost, salt, key, state init state, state expand key, state, salt, key, repeat, state expand key, state, 0, key, state expand key, state, 0, salt, return state. Init state works as in the original Blowfish algorithm, populating the P array and S box entries with the fractional part of in hexadecimal. The expand key function does the following. Expand key, state, salt, key, 4, n equals 118, pn key, 32, n1, 32 n1 pn. Treat the key as cyclic, text encrypt, salt, 063, p1 text, 031, p2 text, 3263, 4, n equals 29, text encrypt, text salt, 64, n1, 64 n1, encrypt using the current key schedule and treat the salt as cyclic, p2 n1, text, 031, p2 n text, 3263, 4, I equals 14, 4, n equals 0. 127, text encrypt, text salt, 64, n1, 64 n1, as above, c, 2n text, 031, c, 2n plus 1 text, 3263, return state. Hence, expand key, state, 0, key, is the same as regular Blowfish key schedule since all XORs with the all-0 salt value are ineffectual. Expand key, state, 0, salt, is similar, but uses the salt as a 128-bit key. The full Bcrypt algorithm utilizes these functions to compute a hash from a given input derived from the password, as follows. Bcrypt, cost, salt, input, state X Blowfish setup, cost, salt, input, text or fee and beholder scryed out T3 64-bit blocks, repeat, text encrypt ECB, state, text, encrypt using standard Blowfish in ECB mode, return concatenate, cost, salt, text. User input. The mathematical algorithm itself requires initialization with 1832-bit suitcase. The original specification of Bcrypt does not mandate any one particular method for mapping text-based passwords from userland into numeric values for the algorithm. One brief comment in the text mentions, but does not mandate, the possibility of simply using the ASCII encoded value of a character string. Finally, the key argument is a secret encryption key, which can be a user-chosen password of up to 56 bytes. Note that the quote above mentions passwords up to 56 bytes even though the algorithm itself makes use of a 72-byte initial value. Although Provos and Mazières do not state the reason for the shorter restriction, they may have been motivated by the following statement from Bruce Schneer's original specification of Blowfish: the 448-bit limit on the key size ensures that the every bit of every subkey depends on every bit of the key. Implementations have varied in their approach of converting passwords into initial numeric values, including sometimes reducing the strength of passwords containing special characters. See for example February 1, 2010 Bcrypt Security Advisory or changes in crypt Blowfish in 5.3 Philippine pesos. 7. See also Crypt, password storage and verification scheme, Blowfish, script, key stretching, PBKDF2, references. External links, Bcrypt file encryption program homepage. Bcrypt is also the name of a cross-platform file encryption utility implementing the Blowfish cipher, developed in 2002.